Have you ever wanted to play with someone's mind, doing weird things in their environment to the point where they lose their marbles and start thinking they're going insane? I know I have. So anyway, here's a little device that will help you do that. It's basically a device that plays a tone at random intervals, but also has a few other little tricks up its sleeve as well. It's based on an Arduino Uno, although you could use the Arduino Nano if you wanted to, and I'm sure you could even take the concept and apply it to the Raspberry Pi and even the Raspberry Pi Zero if you really wanted to go bargain basement cheap. I'll take you through the components. First of all, here's the Arduino Uno, and I've got two piezos or piezos, I'm not quite sure. One makes a sound and one detects a sound, because our piezo can be used in both directions. So the principle of operation is quite simple. In the code, you would set up a random period, say an hour. You'd also define a melody as a series of notes, and then the Arduino will play that tone at a random interval, and then to work out the next random interval, it'll take the time you've put in, and then basically pick a time between now, when the sound has just happened, and 2 times the period you've put in. So if you put in an hour or as the period, then the next random event will occur between now and 2 hours from now. But then the interesting thing about it is the sensor piezo actually detects loud bangs in the environment and will play the tone when it detects a loud bang. So just to really play with someone's mind, there's more interaction going on. But in the code, if that happens, if it does detect a loud noise and sets off a tone, there is a timeout in which it will not repeat. So if someone bangs the table, hears the tone, and they think, I found it, and they think they're going to bang the table again to get the sound again, it's not going to work until the timeout period expires. So let's take you through the code very quickly. I'm going to put this up on GitHub. First of all is pitches.h. Now that's just basically a definition of various notes as frequencies. I've got a start melody which plays whenever the unit is switched on. I'll show you that in a second. That's just to let you know the speaker's connected. Sorry, the piezo's connected. Oh, of course, yeah, you can actually replace the piezo with a regular speaker if you so wish. The worry tone is the tone that is played. In this case, it's 3 rising tones repeated. So it's do-do-do, some settings. The sensor level, that's just a placeholder, which is going to be, that's the actual placeholder for the value that is detected by the piezo. Up here, I actually define the sensor threshold as 55. Up here. But if you're using it, you might want to adjust it to suit the piezo you're using. The next run is basically the time that the next tone will happen. It's an unsigned long because I'm using the millis function. Now, the millis function in Arduino returns the number of milliseconds since the device was switched on or reset. So it's better than using delay, because delay blocks. So you just basically look at the current return value coming back from millis and work out what time it is and when the next thing is to go. Intensity is just to define when roughly the next tone will happen. In this case, I've set to 60,000, which is 1 minute, but in reality, you'd probably put it to something like 600,000, which is an hour, or was it 347,000 something? Sorry, 37,400,000, which I believe is 1 day. The start delay is how long the device will sit before it starts to actually start making noises. That's to give you a chance to sort of set it up and then walk away. The shock repeat delay is when the shocker goes off, how long does it wait before reacting to the shocker again, which that's the piezo detecting a shock. And the last shock time is just a placeholder for the last time the shocker went off. So to work out when it's the timeout occurs, it basically adds that to that and says, is it in advance of millis? So that'll get set to the millis time when it happens. Some setup code here. I've got the serial and hello world going out into the serial monitor just for debug purposes. You can take that out if you want. Plays the startup tone here, which is a separate function. You pass in the array being C-based. It's you passing it by reference. And also, you must always pass in the length of the tone as well, the number of items in the array. That's just a restriction on C, the way Arduino implements it. Now, of course, if you put in more, you're probably going to, if you put in more notes than the melody has, you're probably going to get an error. But if you put in less, it'll just play those. So if you've got a 6-tone melody and you pass in 2 for melody size, it'll just play the first 2. So then we go into our loop. First of all, read the sensor level. And if the sensor level is above a certain threshold, it'll go off. But also it has to be above 5,000 milliseconds from switching on. That's just because there's when you switch it on, things start to pulse around and found with the piezos, and they hold a charge. So you also want to make sure that charge discharges, so it doesn't trigger an accidental triggering. And milliseconds is sorry. And then we go on to working out when the last shock time was. So we take the shock repeat delay, add it to the last shock time, and if that's greater than milli, then we can trigger the shock. And if so, play the tone, and then update the last shock time with the current time in millis, and then return. And then return within the main loop just basically restarts the main loop. You can't ever exit out of this loop in Arduino. Then the next, if this if statement doesn't get executed, we move on to the next one. It basically goes, if milli is greater than the next run and the start delay, work out when the next run will be. So that basically works out a random factor, or a random number between the current time and your intensity time 2. Play the tone, and the loop continues on. So it's basically constantly checking the current time coming back from millis to see if the next random tone can be played, which the next random tone would have been saved into the next run. So it's really quite simple. I'm going to show you it in action. I'm actually going to just play it using a bog standard USB power bank. So if I just plug it in here, and do this with 2 hands, sorry, 1 hand. Yeah, come on now. That's the startup tone. I've got a start delay of 10,000, which is 10 seconds. So it's probably started up now. So I'm just going to give this a tap just to show you what happens. Oh. That's the tone. But if I tap again, nothing, because I have to wait another 10 seconds to trigger it again. So I think that's probably 10 seconds has passed. Let me see. So, but I can't do it again. So there you go. That's how it kind of works. I don't know what the random time is for the alarm to trigger randomly. I think I have it set to 1 minute, so it could happen while I'm talking. But yeah, it's a little. I think this is a nice little bit of code if you're interested in Arduino and you want to get started mucking around. Alternatively, it's if you just want to wind someone up, use this, because it's a good way of getting to people. You can actually buy such devices ready-made from I think it's ThinkGeek, but no, this is something you can make yourself just for the fun of it. As far as I can tell, the power drain is about 35 milliamp hours on the Arduino. This is an 1800 milliamp hour power bank, so that should be good for roughly a month and a half, maybe. Thereabouts. Probably not as good as that, probably less than that, but that's optimistic. If you're going to use it, hide it in a roof space. That dampens the sound a bit and makes it harder to find. And don't set the intensity too short. No, you want to go for like a full 24 hours just to, just to play with people's minds enough. But anyway, yeah, simple little device using 2 piezos, which costs pennies in Maplins. You can use any Arduino you want, the Nano right up to the Uno and even the Megas. Yeah,